Don't tell me we have 56 errors. This will be like a fake EEG. It's still time series data. It's loading forever. I mean, later we can add the other shapes to it as well that might be more EEG relevant, like a spike. And have an envelope of a spike or slow wave EEG. And this particular tool is using fuzzy logic to try and detect this signal. Tool is using fuzzy logic to try and detect this signal. Currently, alright, we have to update this HTML because we actually need the charts in it. We're actually using GitHub Copilot, which meant to be GPT-4. Okay, no, I meant with the charts. We need the charts visible. We have charts, and no, it's the ID, the charts. We need the charts visible. We have charts, and no, it's the ID, output wave, input wave. No, the input wave is already there. That's the drop down menu. We actually need the chart as well. So we do have the input graph and an output graph, but we don't see them. Where are they? The input and output graphs are not displaying anything. How do we fix that? Plotly library is correctly imported. Yeah, Plotly library is loading forever. Don't know why. Check if the data is there. I suspect there's no data. Check noisy signal. Update input graph. Log noisy signal to console. Generate signal is not defined. Never understand this main.js 4222, 4222. Which one is it? I'm not having that labeled by the linter. It's a template, isn't it? Need to replace this. Yeah, this should be a function. Yeah, it's all templates so far. That error should go away. Okay, there's something wrong with the loading time. Where's the network? No, those errors are actually okay. Yeah, it's loading the Plotly, so we do have the data. Looks like it's overlaid on top of a sinusoid. Yeah, we can add noise, which is great, and the output is not doing anything because we don't have that functionality yet. This CDN seems to be loading forever. Well, forever, it's eventually loading, but it's way too long. And it's meant to be a mini version of it as well. The other problem is obviously the output. Yeah, the output shouldn't be a selection. It definitely shouldn't be a drop-down menu. It should be an output, right? So let's change that. I mean, it could be an input only if we are training, but we are not training at the moment. Should we change it? Yes. Label for output. Yeah, output data is not updated. We need to update for output wave. So in HTML we have that, okay. And in JavaScript, update output data. It won't work, but okay, because we don't actually have the output data. We also don't need this constant, so the output should be displayed as text. That won't work, would it? Output wave. Okay, we actually need the input waves to work properly. Are we generating the functions in Python code or JavaScript? It's okay to generate them in JavaScript. I want to do as much as possible on the front end so my server is not overloaded. And we can add the sinusoids as well. A square works. And they have a triangle. Default is still sine wave. case left trapezoid doesn't work, square works, and there is no output. Don't have those functions, do we? No. Graph is updating. We have the noise, everything doesn't work, ends up being a sinusoid, and there is no output. The analyze doesn't do anything anymore, does it? Yeah, that's just a mock-up. Generate signal, add noise, analyze signal, calculate detection error, calculate unknown percentage. That sounds much better, doesn't it? Why couldn't you just do it to begin with? Not dropping frames anymore in my stream, but JavaScript is loading forever. Put wave is empty. Detection error is always 0. Send unknown is always 0. We want to display that with wave detection error and unknown percentages. Or HTML. Let's check HTML control. Put wave. You already have that. Detection. Get output in JavaScript function. Do we have this function? It should be better. Does it make sense? Having an error in JavaScript. That's 67. That's where the error is from. Noise plus signal. Yes, where the error is from. Noise plus signal. Yeah, those are just templates. That doesn't work. Place your actual code to calculate a no percentage. It should be signal. Noise signal should be input and output. It should be using fuzzy logic. Yeah, that's right. Yeah, okay. Python code should do a fuzzy logic. Python fuzzy logic library. Yeah, this is not quite right. It's just an example. That's a good start to install this library. When it's not noisy, it's game 2.5. It's noisy, it's game something else. Yeah, we need to check. Editing videos with the music in it will be very difficult. Let's give something else. Yeah, we need to change. This one doesn't have the music yet. Changed. Yeah, so the one good. This was an attempt to do a funny avatar or whatever that didn't quite work. I mean, the avatar is working, but the thing needs improvement. The thing about LabVIEW was not using it anymore, mainly because of the cost of the license, but it had the toolkit for designing fuzzy logic, so these membership functions. Essentially, it's taking out the features from the signal. One thing is for sure, output wave should predict, detect input wave, so the values should be the same. You can simply return the input wave. Yes, we do want to perform the fuzzy logic. No, that would not do it. The issues with the labels, should have left them as they were. So it's giving me the sinusoid. I don't know why. Yeah, we need to. The fuzzy rules is more than just a template. So originally, I think it was looking at 3 sensors, but this example is better than taking issues with the tool. The output. This output wave should be a text, obviously. Error message I didn't see. It's a float. Right. That video looks alright. I just need to hit the Control R to remove any missing bits, missing clips, whatever they're called, segments. So we have 11 minutes. It's fine. 11 and a half. Save that. See if we can render while live streaming. Render. Told you this stream will be chaos. Let's render this. See if we're dropping any frames in the live stream or not. So far so good. Might be the noise from the GPU might be coming through the microphone. I'll edit it later. Obviously this content would not be a standalone video. It's just a Saturday live. We have the text on the window. I don't know if I still need it or not. And sorry for the birds. Birds will definitely go through the microphone. So wherever you can choose, it's a weekend. We can choose wherever I can do the fuzzy logic stuff, or go back to this music and gesture generation. And gesture generation. Okay, so finished the rendering. Save that. Can close this. Start developing in a second. I'll mention this in a second as well. Just pop the video. It's real behind the scenes, isn't it? Tutorial how to upload a video onto YouTube. Yeah, I'm pretty sure there will be lots of those. Alright, need the name for it. I need the name for it. That fuzzy logic one. Yeah, that must be the first fuzzy logic video. Just rename this quickly, just so I... Yeah, this will be also a multi-part thing. Just double check the video quickly. Basically, checking that it has audio and everything in it. So this membership functions. Essentially, it's taking out pink frames. Yeah, thumbnail. There's a big thing on YouTube with thumbnails, whatever. But no, my thumbnails are always, well, almost always from the video itself. Logic part 1, it's like 400 megabytes, so it might take a while to process. She had a better name for it. I don't know why we're not using it. Yeah, it's noisy waveform. Well, yeah, it will be eventually it will be synthetic EEG. This is tool dev. Yeah, this will be part 1. So we let it load. So eventually, hopefully, it will appear on Bionichaos. I don't know. When? It's a good question. Yeah, the last tool is still the EG2 musical version, and then we also have this one, but haven't been packaged into a publishable thing yet. Need to change the layout and everything of this HTML, but it is available. It's already running. So, but it's only it's essentially unlisted. So you only get the link if you watch those live streams or have me on LinkedIn. Let's see quickly. Yeah, we have some people joining in and leaving, probably because yeah, this live session is meant to be interactive, so I'm happy to chat. Well, because it's Saturday, pretty much about anything, but preferably anything related to bionichaos.com. So any of those tools or future development. Part 1. Yeah, it's interesting when people join in the stream, they actually end up watching other videos. So you can see 3 people joined, left. One of them must have watched another earlier video. And yes, if you're interested. Yeah, this one keeps attracting quite a lot of views. That's probably a full view. Some of the views are incomplete. This particular video got the... Alright, it's a live stream. That's interesting. Yeah, some of the live streams later get turned into standalone videos somehow by YouTube itself. This one will have... that's interesting. It doesn't have the description. Yeah, it's full disclaimer. We're using ChatGPT to generate descriptions to videos as well. This was an old... When was it published? An old video. like almost 100 days ago. Does it have subtitles? Yes. So what do we do with subtitles? Yeah, we did go to edit timings and we download them. And this will be a long one. And we pop it into ChatGPT, ideally for the YouTube captions. Yes, so there's a prompt. Generate content title. Right, so we have this prompt saying generate descriptions, description paragraph, first person. Well, yeah, because it's my video. Generate timestamps, generate a single paragraph of tags, finally generate better title. And yeah, someone said that if you promise ChatGPT to give it a tip at the end, if it covers all the video segments, I'll yeah, give it a tip.
Sure, I'm ready to assist with your request. Please provide the captions and timestamps for me to work on.
Okay, so this is nice to actually talk to someone. Well, because we don't have anyone in the stream, so might as well talk to a bot.
First person description paragraph. I started my live coding session by checking if the streaming was live and adjusting to the delay caused by the streaming software. Once live, I could hear myself with a delay of about 5 to 10 seconds. I began by working on a Flask application, troubleshooting various issues, including error plots and handling JSON responses. Throughout the session, I interacted with my audience, seeking their participation and feedback. I encountered numerous challenges, including debugging errors and refining the application's functionality. The focus was on developing and refining a tool for diagnosing HG mix. The session was an iterative process of coding, testing, and problem solving, showcasing the real
Can you focus on the technical items? Technical items, and also make sure the timestamps are in the following format. Yep. Let's regenerate that stuff.
first person description paragraph. During my live coding session, I focused on developing a Flask application. I started by ensuring the streaming setup was correct, with a notable delay of approximately 5 to 10 seconds. My work involved extensive debugging, particularly with error plots and JSON response handling within Flask. Key aspects of the session included refining the tool for diagnosing HG mix, managing JSON responses, and addressing various coding challenges. The process was highly iterative, involving coding, testing, and troubleshooting, highlighting the complexities of software development. 0 hours 0 minutes and 9 seconds checking streaming setup and discussing the delay. 0 hours 26 minutes and 40 seconds confirming audio. Certainly. Based on the provided captions from your YouTube video, I'll focus exclusively on the segments related to the Flask application development and troubleshooting. Let's create a concise description and timestamps for those parts. First-person description paragraph. In my live coding session, I dedicated my efforts to developing and refining a Flask application. The session involved tackling a variety of technical challenges, notably debugging issues and optimizing the application's functionality. I focused on error handling, JSON response management, and integrating HTML and JavaScript. The process was a deep dive into the intricacies of Flask development, demonstrating real-time problem-solving and code refinement. The interaction with my audience added a collaborative dimension to this technical endeavor. 0 hours 2 minutes and 10 seconds beginning Flask application development and addressing initial debugging. 0 hours 3 minutes and 0 seconds managing JSON responses and error handling in Flask. 0 hours 4 minutes and 4 seconds shifting focus to HG mix diagnosis tool within the Flask framework. 0 hours 6 minutes and 16 seconds engaging in live troubleshooting and audience interaction. 0 hours 7 minutes and 1 second delving into literature review related to the Flask application. You're right, and I apologize for the oversight. The timestamps I provided only cover up to the 20-minute mark, which doesn't account for the full length of your video. Let me correct this by generating a more comprehensive set of timestamps that reflect the entire duration of your 2-hour and 20-minute Flask development session. 0 hours 2 minutes and 10 seconds starting with Flask application development and initial debugging. Thank you for clarifying. I'll review the provided transcript and generate a comprehensive set of timestamps focusing on the Flask application development throughout your 2-hour and 20-minute live coding session. Please allow me a moment to go through the transcript and prepare the timestamps. Comprehensive timestamps for Flask application development. 0 hours 2 minutes and 10 seconds. 640 initiating Flask application development, discussing the starting tool. 0 hours 2 minutes and 39 seconds. 240 transitioning the tool into a Flask application. 0 hours 3 minutes and 0 seconds. 880 dealing with an error in the Flask app, examining existing code. 0 hours 3 minutes and 22 seconds. 600 attempting a fresh start to resolve.
Okay, can you make sure you read the entire transcript? The whole 2.5 hours. Then regenerate the description. Yeah, don't just have to. It's not doing great.
First-person description paragraph. In my recent live coding session, I delved deep into developing a Flask application. The focus was on resolving complex issues, particularly in handling JSON responses and error management. My journey included integrating HTML and JavaScript, fine-tuning the app's functionality, and enhancing the HG mix diagnosis tool. The session was a hands-on exploration of Flask, involving real-time debugging, code refinement, and audience interaction for troubleshooting. I navigated through various challenges, offering insights into Flask's intricacies and the process of building a robust web application.
Okay, that sounds legit, but did it provide... The whole lot is like 20. How long is it? Can you check how long the video is and regenerate last response for the entire length of the transcript? Should be around 2.5 hours. Yep. Yeah, now it's going every 10 minutes or so. Just okay. Can you rewrite the title? The fact that the stream is 2.5 hours is irrelevant. Yep. Oh, come on. Yeah, that sounds better. Why is it mastering Flask? What was the Flask application about? What was the Flask application about? Yep.
The Flask application discussed in your live coding session was focused on diagnosing HG mix. Throughout the session, you tackled various aspects of developing this tool within the Flask framework, dealing with JSON responses, error handling, and integrating HTML and JavaScript. The application's primary purpose appeared to be related to medical or health technology, specifically aimed at diagnosing or analyzing HG mix, which could be a condition or a term related to your specific project or field of work.
Why did it get the HG? It must be EG, is it? HG mix. Maybe it's something else. Yeah, I have to check. HG of ECG mix diagnosis. Right. Of wait again. Get to that in a bit. Review on the topic of ECG mix diagnosis. What's ECG? Yeah, that's why you shouldn't rely on YouTube. Just Google automated transcription. Might get to that in a bit. Let's actually start another chat. Just pop this in because before we started with the code and then gave the bot the error message. But well, there is no way I'm going over 2.5 hours. Just publish this one, should correct the we can edit it as well. Maybe we should edit it to something shorter. Do a trim and cut from within YouTube. Yeah, it doesn't really like long videos. Yeah, it's still loading the player or something. I just leave it there. Just jumping to a different topic. Because this paper I was trying to extract the data from. It was trying to use matplotlib numpy to extracting the XY coordinates, extracting the data points, but it had trouble doing it. Didn't actually recognize the y-axis and generated its own y-axis. I don't know why. It generated its own x-axis as well, because originally I thought it was missing in the image, but it's actually there. Yeah, I didn't see that. It's actually live. How to show when exactly it's done. Right, so yeah, that video loaded okay. So we can trim with all this stuff in the beginning. Software should be live now in theory. Hear myself. We'll start in a second. Yeah, this editor is not great. Yeah, there's a huge gap there we can get rid of. Let's post that quickly. It into it. It's super slow. This tool. So still. Right, so we want to trim the beginning. Was it only 2.5 minutes? No. Is 0 to that time, yes. Can probably trim some at the end, not sure. Yeah, there are gaps in it as well. Oh, it's a huge gap there. Actually remember editing it myself, regardless of what I do. Oh. Let's do a cut. It's suggesting me to cut all that. Maybe I should. Eventually this thinks it's some sort of silly mistake that I've made, but I can't see. Yeah, in the editing I normally get about 10-15 minutes out of an hour. So of, right, just save it as that. Yeah, and that will, it says there's a problem doing something on a public cloud, not your own, so this will take few hours to take effect. It's okay, as long as we remember to go back to it later. So that 11-minute video is ready. That's part 1, suggesting us this, yeah, because again I said I'm not doing custom, what are they called, thumbnails, just choosing one from the video itself. Sometimes I do go and generate a different one because it's suggesting you 3 options. Sometimes they are not great. Let's create a new playlist. We'll select that by default. Yeah, doesn't really matter, they're pretty much the same. That one it's not good because it has some other materials, probably one of the papers that I briefly mentioned. And yeah, there's a lot of other settings. Yeah, this thing. Yeah, don't like that as well. I have to change it for all the videos. That's how I set up YouTube originally, but yeah, apparently this finds keywords that are in your video and tries automatically with AI, whatever, explain them in the description of the video. And this featured places is actually finding, as I speak, if I'm in a fancy restaurant somewhere, it will actually mention the place. So, well, obviously in my case, hopefully it won't be able to do it. Well, because I'm not in a public space, and I don't need it to do it. It might get something wrong as well. Yeah, we do publish everything under Creative Commons license. We don't use the standard YouTube thing. Allow video and audio remixing, that's fine. Science and technology, yes. There's a basic comment moderation. Just another algorithm that potentially holds inappropriate comments. That's okay. Yeah, sure, how many viewers like. Yeah, it's really tempting to get rid of it. I will leave it there. Yeah, we have to review the settings for the whole video as well. For our videos, or the default settings. So it's either for past videos or new videos that I upload. So yeah, there are options to go private, unlisted, or public. We'll go public. schedule, no, just publish now. And that one should go live. We have the link for it. There should be a new video on the channel. That didn't work. Generating the captions didn't work. Well, we edited the video a bit, so it should be shorter now. It should be about it'll still be around 2 hours. So I'd close this. Yeah, that didn't work. We tried to extracting data from a chart like this. It didn't work. It's getting confused by the excess values. It generated its own, because obviously couldn't determine what's on the chart. So yeah, said it's not feasible. So we can close that as well. Just might as well start a new chat. Yes, we had another. Yeah, that video will be editing for some time. It's very long. Let's go to analytics again quickly. We had someone. Yeah, it's not showing. Oh, not yet. Anyway, if anyone is interested in YouTube analytics, I could generate content on that. I'll just talk about it now. Yeah, it's primarily all about the watch time that the algorithm cares about. But yeah, not of great interest to me, but if it's something that interests you, do let me know. So we had this Flask application. Just run it now. This is a simulated EEG. This is simulated EEG. I'm trying to do fuzzy logic analysis. It will be a waveform detector. Meant to have this scroller. So the idea is that you have this baseline EEG. Yeah, that amplitude looks legit. Go about 0.3 plus minus 0.3, and then you'll have a big EMG artifact every now and then. And we should have the fuzzy logic being able, ideally, to detect it. I'll say what's the probability of EMG in the signal is based on these parameters. So we'll start the new chat. Yes, if you wanted to switch talking about the hand gesture to music conversion, do let me know, because it should be more fun. Let's do I'm thinking, should we do requirements log info? That info would not be correct, would it? Yeah, that's the old one. Yeah, I'll update that one. So we're designing a Flask application. We, by the way, live streaming on YouTube as well together. So welcome as my co-host. So the Flask application, we already did a couple of sessions on it together, and we already have some code. We have a HTML file, a JavaScript file, a Python file that is the Flask application, and a CSS file as well. So I'll be sharing them next with you. Yep. Let's see if it understands the context.
Hello, Dr. Benno. It's great to be a part of your Flask application project and your YouTube livestream. Feel free to share the files whenever you're ready, and we'll dive into the next steps of development together.
Right. Clear. Doesn't work.
Great. The HTML structure for your fuzzy logic waveform detector looks comprehensive and well organized. It seems to offer a user-friendly interface for exploring waveform detection using fuzzy logic, which aligns perfectly with your project's focus. If there's any specific area you'd like feedback on or assistance with, let me know. Looking forward to the next part of your code. Your JavaScript function fetchEEG is well crafted for asynchronously fetching EEG data and handling potential errors effectively. The displayEEG function integrates smoothly with chart.js to visualize the EEG data in a line chart, which is ideal for EEG signal representation. The use of window.eeg chart to check and destroy an existing chart before creating a new one is a good practice to prevent memory leaks and ensure the chart updates correctly. If you need any specific feedback or assistance with further code, feel free to share. Looking forward to the next part. Your Python Flask code nicely integrates with the front end, offering functionalities like EEG data generation, preprocessing, and fuzzy logic-based analysis. The generate_synthetic_eeg function simulates EEG data with added artifacts, which is a creative approach for testing. The analyze_eg function leverages fuzzy logic to assess artifact risks, demonstrating a practical application of fuzzy sets and rules. The Flask routes are well structured for serving the application and handling EEG data generation and analysis requests. The usage of try-except blocks for error handling in your routes is a good practice to enhance the robustness of your application. If you have specific questions or need further assistance with this code, feel free to ask. Ready for the next part. The CSS you've shared sets up a visually appealing design for your EEG data visualization tool. The use of CSS custom properties, variables, like Miradors1, Miradors2, etc., is a good practice for maintaining a consistent color scheme throughout the application. The styling for the #EEG-chart-container and #EEG-chart elements is particularly important for your EEG visualization. The horizontal scroll on #EEG-chart-container allows users to navigate through the EEG data timeline effectively, which is crucial for detailed analysis. The width and height of #EEG-chart are set appropriately for displaying the data, though you may need to adjust the width based on the actual amount of data and how you want it to be displayed, e.g., width per second of EEG data. If you have any specific design considerations or functionalities in mind that you'd like feedback on, feel free to mention them. Looking forward to more details or further questions you might have.
The GPU is getting really warm. Gets really warm in the room. To probably open the window some more, whatever. Clear. Right, that did work. Clear. Yeah, I don't know what's up with my microphone. It's probably because I'm using it obviously for the streaming. It's the same microphone. Hopefully the stream sound still sounds okay. I haven't checked for a while. Right. Oh, that's okay. That's okay. Okay, there are a couple of issues. There are a couple of issues with the code. Can we make sure the scroller actually works? Because currently the whole waveform is shown. Yep.
To ensure the horizontal scroller for the EEG chart works correctly, we need to adjust the CSS so that it properly handles the width of the chart in this container. The goal is to make the container smaller than the actual chart, enabling scrolling. Here are some steps you can take. Set a fixed width for the container. Define a specific width for the #EEG-chart-container that's smaller than the total width of the #EEG-chart. Dynamic width for the chart. The width of #EEG-chart should be dynamically calculated based on the length of the data. For instance, if you're displaying 100 seconds of data at a sampling rate of 250 Hz, and you assign 1 pixel per data point, the chart width would be 250 pixels * 100 seconds. CSS adjustments. Ensure that overflow X is set to scroll for the container and that the chart has a larger width than the container. Here's an example of how you might adjust the CSS. In your JavaScript code, ensure that when you generate the chart, you set the width of #EEG-chart dynamically based on the data length. If the scroller still doesn't work as expected, you might need to check for additional CSS that could be affecting the layout or ensure that the chart library you're using, like Chart.js, supports such a dynamic resizing app.
Well, this one did something. It made the window of the chart smaller, but it's still displaying the whole data, so I'm not able to actually scroll through it. Yep.
If the entire dataset is still visible without the need to scroll, it likely means that the chart itself is not extending beyond the bounds of its container, #EEG-chart-container. To enforce the scrolling, you need to ensure that the chart's width is significantly larger than its container. Here's a revised approach. Set a fixed width for the container. The container's width should be set to a fixed size that is smaller than the total expected width of the chart. Dynamic width for the chart. The chart's width should be dynamically set based on the length of the data. This width should be calculated in a way that it extends beyond the container's width. Adjust the chart generation logic. When generating the chart with JavaScript, ensure that the canvas #EGChart width is set according to the number of data points. For example, if you have 1000 data points and want each data point to be 1 pixel wide, the canvas width should be 1000 pixels. Here's an example of how to adjust the CSS. In your JavaScript code, dynamically set the width of the #EGChart based on the data length. For instance, this should create a horizontal scroll bar in the container when the chart's width exceeds the container's width. Ensure that the chart.js settings, or whichever library you're using, do not constrain the chart size inside its parent container.
Can you double check what I currently have as code within the display EEG data function? And could you regenerate the whole function with the necessary updates? Yep.
Absolutely. Let's review and update your display EEG data function. The aim is to dynamically set the width of the chart based on the length of the EEG data so that it extends beyond the bounds of its container, thereby enabling horizontal scrolling. Here's your current function with necessary modifications. Key changes and considerations. Dynamic width. The width of the canvas is set based on the length of the EEG data, chart width. Adjust the formula for chart width as needed, depending on how you want to scale the data points. Responsive option. Set responsive to false in the chart.js options. This prevents the chart from automatically resizing to fit its container, which is necessary for the scrollbar to function as intended. Maintain aspect ratio. Set maintain aspect ratio to false to allow independent width and height scaling. Data mapping. The labels in the dataset are generated based on the data index. Adjust the mapping if your data is sampled at a rate different from 250 Hz. Test this updated function with your existing setup to see if the horizontal scrollbar behaves as expected. If there are any issues or specific behaviors you're aiming for, let me know.
Okay, this works better. Now we also would like, can we double check that we actually generating the EMG artifact, the chewing artifacts, and because later we want to have them in the data while scrolling through. So essentially we'll need this, we'll need to generate a longer data set with the EMG bits embedded into it, so we can scroll through, and later for the fuzzy logic algorithm to mark, to give a percent likelihood for EMG in the signal. Yep.
To ensure that EMG chewing artifacts are correctly generated and embedded in the EEG data, let's review and potentially refine the generate_synthetic_EEG function. This function should create a longer EEG dataset with EMG artifacts at regular intervals. Later, you can use this data with the fuzzy logic algorithm to mark and assess the likelihood of EMG artifacts. Here's a review of your generate_synthetic_EEG function with some suggestions. Longer dataset. Increase the length parameter to generate a longer dataset. This allows for more data to scroll through and more opportunities to embed EMG artifacts. Artifact frequency and duration. Adjust the frequency and duration of the EMG artifacts. This is currently controlled by the loop for I in range 0, length 10. You can change the length, 10 part, to control how often the artifacts appear and their duration within the signal. Artifact intensity, the amplitude and characteristics of the EMG signal are set by NP. Random, normal, 0, 0.2, length, 10. Modify the parameters of the normal distribution to change the intensity and variability of the EMG artifacts. Filtering parameters, the butter_bandpass_filter function is used to filter the EMG signal. Ensure that the EMG_FRQ range and filter order are appropriate for the type of EMG artifacts you want to simulate. After adjusting the function, you'll want to visually inspect the generated data to ensure the artifacts are present and realistic. You can plot a segment of the data using a library like Matplotlib in Python, or simply observe the waveform in your web application after scrolling through the EEG data. For the fuzzy logic algorithm, you'll need to decide.
Have you actually modified the generate synthetic EEG function, or just made suggestions? If you didn't modify it, can we regenerate the whole function without any placeholders? Yep.
Certainly. Let's create a modified version of the generate_synthetic_EEG function without placeholders. This version will generate a longer EEG dataset and embed EMG tuning artifacts at regular intervals. The function will be structured to ensure clear artifact generation for later analysis with the fuzzy logic algorithm. Here's the revised function. Length of the dataset, increased to 5,000 data points, which corresponds to 20 seconds of data at a sampling rate of 250 Hz. EMG artifacts, the EMG_amplitude parameter sets the intensity of the EMG artifacts. The artifact_interval parameter controls how frequently the artifacts are inserted into the EEG data. Artifact generation, the loop now considers the remaining length of the EEG signal to prevent array overflow when adding EMG artifacts near the end of the data. This function should now generate a longer EEG dataset with clearly defined EMG artifacts. You can adjust length, EMG_amplitude, and artifact_interval as needed to fit your specific requirements for the data visualization and analysis.
Okay, I tried this code. It seems, is it all EMG now? There seem to be no baseline EEG in the data. We need to correct this. Also, can we make sure the window of the chart remains the same size and fits into the window on the front panel? Yep.
If the generated data seems to be predominantly EMG without a clear baseline EEG signal, we need to adjust the balance between the baseline EEG and the EMG artifacts in the generate_synthetic_EEG function. Let's correct this and also ensure that the EEG chart fits properly in the window on the front panel. Here's the revised generate_synthetic_EEG function. Key changes. Reduced EMG amplitude. The EMG_amplitude is lowered to reduce the dominance of EMG artifacts. Shorter EMG artifact duration. EMG artifacts are now shorter in duration, making them less pervasive throughout the EEG signal. Artifact frequency. The artifacts are introduced less frequently, ensuring a clearer baseline EEG signal. Regarding the chart window size and its display on the front panel, you'll need to adjust the CSS and JavaScript to ensure the chart fits within the designated area and allows for scrolling. Ensure that the #EEG-chart-container has a fixed width.
Okay, this is better now, but the EEG looked better before. It looked more realistic before the last update of the code. The EMG, periodic EMG in the code, in the data looks great. Can you regenerate the CSS file with the necessary changes? Yep.
I'm glad to hear the periodic EMG artifacts are appearing correctly in the data. To adjust the EEG signal to make it look more realistic like before, while keeping the EMG artifact improvements, we can slightly modify the generate_synthetic_EEG function. After that, I'll also provide the necessary CSS adjustments to ensure the chart fits well in the UI. Let's start with the generate_synthetic_EEG function. Added a small amount of random noise to the baseline EEG signal to make it look more realistic. Now, for the CSS. Ensure that in your JavaScript function which displays the EEG data, the width of the #EEG chart canvas is set dynamically based on the data length. This setup should maintain the chart within its container, allowing for horizontal scrolling while viewing the EEG data. If you need further adjustments or have other specific requirements, please let me know.
It looks okay. The signal looks okay. The data looks okay, but the window is not right. The signal is outside the viewable part of the chart. Can we fix that? Outside the viewable part of the chart. How do we fix that? Yep.
If the EEG signal is extending outside the viewable area of the chart, it suggests that the chart's dimensions or the scaling of the data within the chart need to be adjusted. Here are a few steps to correct this. Adjust canvas size in JavaScript. Ensure that the width of the canvas, #EEG chart, is set dynamically based on the data length in your JavaScript function. This is crucial for the chart to accommodate all the data points without overflowing. Ensure proper scaling in chart.js. If you are using chart.js or a similar library, verify that the data is properly scaled to fit within the chart dimensions. This might involve adjusting the scales in the chart options. CSS adjustments. The container, #EEG-chart-container, should have a fixed width and height, with overflow X set to scroll and overflow Y set to hidden. This ensures that if the chart is wider than the container, a scroll bar will appear, allowing you to scroll through the data. Responsive and aspect ratio settings. In chart.js, ensure the responsive is set to false and maintain aspect ratio is also set to false. This prevents the chart from resizing automatically to fit its container, which can cause issues with how the data is displayed. Here's an example of how you might adjust the CSS in the chart options. JavaScript chart options. Make sure to adjust the width of the canvas based on the data length when creating or updating the chart. This should resolve the issue of the signal extending outside the viewable area. If you encounter any more issues, please let me know.
Okay, so this is in JavaScript. And we already have that. Oh, come on. Clear. Yeah, we already have all that. Is it possible to scale the y-axis so it's always visible in the chart? Do we need some sort of auto scaling of the chart? Are there auto scaling options for these charts? Particularly for the y-axis. Yep.
Yes, chart.js, which you seem to be using, offers options for automatic scaling of the y-axis. This feature ensures that the y-axis adjusts dynamically to fit the range of your data, so all data points are always visible within the chart. To enable autoscaling, you can modify the y-axis options in your chart.js configuration. Here's how to adjust your chart configuration for autoscaling the y-axis. Key points for autoscaling. Begin at 0, set to false unless you specifically want the y-axis to start at 0. Auto skip, automatically skips ticks to avoid label collision. Max ticks limit limits the maximum number of ticks displayed. Precision determines the precision of the ticks, number of decimal places. With these settings, chart.js will automatically scale the y-axis based on the data provided, ensuring that all data points are visible within the chart. If your data range varies significantly, these auto-scaling features will help keep the chart readable and informative. If you need further adjustments or more specific control over the scaling, chart.js offers a range of options to fine-tune the chart's behavior. Let me know if you require more detailed configurations.
Okay, so we have begin at 0 at false. The settings for the ticks. It should be scales. Okay, I'm confused. Scales, why? Again, 0, false. Then we have the sticks. Go. Alright, we need a comma. And no, that did then. Oh, come on. Automatically skips, avoid level collision, maximum ticks, needed precision. It's not about the ticks, it's about and now it's even worse. I don't see any of the data on the chart. Is it about the ticks or the auto scaling of the whole window? Okay, we need to redo these charts. The chart, there's a lot of problems with it. Can you regenerate that bit of the code? Yep.
Understood. Let's rebuild the chart configuration with a focus on ensuring proper visibility and auto-scaling of the data, particularly on the y-axis. I'll provide a revised version of your chart setup in JavaScript that should help address these issues. Key adjustments. Canvas width. The canvas width is set dynamically based on the data length. This is crucial for the horizontal scroll bar to work correctly. Chart type. Line is appropriate for EEG data visualization. Y-axis autoscaling. The y-axis is configured to automatically adjust its range based on the data. The begin at 0 is set to false to allow the chart to scale based on the data values. Auto skip, max ticks limit, and auto skip padding are set to ensure that the axis labels are readable and not overcrowded. X-axis configuration. Adjust the X-axis settings as per your data's timescale. Responsive and aspect ratio. Set to false to disable automatic resizing. This setup should provide a more reliable and clear visualization of your EEG data. If the data is still not displaying correctly, it may be necessary to check the format and range of the data being passed to the chart. Please test this configuration and let me know how it goes. If there are still issues, we can explore further adjustments.
Yeah, we definitely need to explore more adjustments. It still doesn't work well. There are also issues with the axis not being visible. The data being outside the visible range on the y-axis. And also the EEG signal label text is moving with the scroller, whereas I'm expecting it to be stationary in one place. Yep.
To address the issues you're facing with the EEG chart, let's refine the chart configuration further. The main objectives will be ensuring that both the X and Y axes are correctly scaled and visible, keeping the EEG signal label stationary while allowing the data to scroll, properly fitting the data within the visible range of the chart. Here's a more detailed approach. Y-axis autoscaling. We need to ensure the Y-axis scales correctly to fit the data. If the data goes outside the visible range, it suggests the autoscaling isn't functioning as expected. We can try a different scaling strategy. X-axis configuration. If the X-axis isn't visible, it may be due to the canvas size or the chart configuration. To keep the label stationary, you can use a separate element in your HTML for the label, positioned outside the scrolling container of the chart. Data check. Ensure the data passed to the chart is in the correct format and range. Canvas size. Verify that the canvas size matches the amount of data you're plotting. Browser rendering. Sometimes, issues can arise due to how different browsers render content. It might be worth testing in different browsers. Test this setup, and let's see if it resolves the issues. If problems persist, we may need to delve deeper into specific aspects of your implementation or consider alternative charging solutions.
It's always easy to blame the browser rendering. I do not want the label outside the chart, as it is okay. I just expect it not to move, always be in the same position within the chart. We make sure the waveform, the data is centered within the chart, is centered on the y-axis. Yep.
To keep the EEG signal label stationary within the chart and ensure the waveform data is centered on the y-axis, we need to adjust the chart configuration. The goal is to modify the chart's y-axis scaling and the placement of the label. Let's tackle these issues. To center the waveform, we need to adjust the y-axis range so that it dynamically fits the range of your data. We'll calculate the maximum and minimum values of your data and set the y-axis limits accordingly. To keep the label stationary, we can use a plugin in Chart.js that allows us to draw custom text on the canvas. This way, the label remains in a fixed position within the chart area. Here's how you can implement these changes. The y-axis is dynamically scaled based on the data's range. Custom annotation, static label, is added using Chart.js's annotation plugin. You might need to include this plugin if it's not already part of your Chart.js bundle. The label remains stationary within the chart. This configuration should center your waveform data on the y-axis and keep the EEG signal label fixed within the chart. Please test this setup, and if there are any further adjustments or issues, let me know.
No, I do not see the label anymore. And also the data is not centered. I expect the signal, the waveform, the data waveform to be centered around 0, and also 0 to be the center of the chart in terms of the y-axis. Yep.
To center the waveform around 0 on the y-axis and ensure that 0 is the midpoint of the chart, we'll need to adjust the y-axis scaling accordingly. Also, I understand now that you want the EEG signal label to be fixed within the chart area, but not external to it. We can achieve this by using a plugin for static positioning or by adjusting the chart configuration. To center the waveform around 0, we need to set the y-axis such that its range is symmetrical about 0. This involves calculating the maximum absolute value of the dataset and setting the y-axis limits to the negative and positive of this value. The y-axis range is set to be symmetrical around 0, based on the maximum absolute value of your data. The legend filter is used to keep the EEG signal label stationary within the chart area. Please test this configuration. If the label is still not appearing as expected, or if the data is not centered around 0, we may need to explore alternative solutions or additional plugins. Let me know how it goes.
Can we update the CSS code as well? Yep.
Certainly, let's update the CSS to complement the changes made in the JavaScript chart configuration. The goal is to ensure that the chart container is styled properly to display the chart with its newly adjusted dimensions and characteristics. Here's the revised CSS. The #chart container is given a fixed width and height, with horizontal scrolling enabled. This ensures that the chart is displayed within a defined area and can be scrolled horizontally if the chart's width exceeds the container's width. The #chart_height is set to ensure the chart fits well within the container. The width of the chart is managed by JavaScript as it depends on the length of the data. Optional CSS for .eg label is provided in case you decide to position a static label within the chart container. This CSS should work well with the updated JavaScript chart configuration. Please test it with your setup, and let me know if there are any further adjustments needed.
The waveform is still not centered, and the label is not in a fixed position. Yep.
I understand the issues you're experiencing. To ensure the waveform is centered around 0 on the y-axis and the label remains in a fixed position within the chart, let's revise our approach. We need to adjust the y-axis range in the chart.js configuration to center the waveform around 0. We'll calculate a symmetric range based on the maximum absolute value of your data. To keep the label in a fixed position within the chart, we can use the before draw plugin hook of chart.js. This approach allows the label to be drawn directly onto the canvas, ensuring it doesn't move with the scroll. The y-axis range is calculated to be symmetric around 0 based on the maximum absolute value in the data. The before draw plugin hook draws the EEG signal label onto the canvas at a fixed position. Please implement this updated JavaScript configuration and test it. This should center your waveform around 0 and keep the label stationary within the chart area. If there are any further issues, please let me know.
In a different browser. Yeah, it's pretty annoying. It's different in terms of the scroller, but the display is the same. the waveform is still below the visible area of the chart. The waveform is still below the visible area of the chart. Yep.
The waveform appearing below the visible area of the chart likely indicates that the calculated y-axis range is not accommodating the data correctly. Since the actual data can't be directly inspected in this environment, we need to ensure that the y-axis range is set up to always center the data around 0. Additionally, the label issue can be resolved by using the title configuration in chart.js, which remains fixed and does not move with scrolling. Let's try to modify the chart configuration with a focus on centering the data around 0 on the y-axis and fixing the label within the chart area. In this configuration, the suggested min and suggested max options for the y-axis are used to recommend the scale bounds, which should center the waveform around 0, with 0 being in the middle of the chart. The title plugin is used to place a static title within the chart area that does not move with scrolling. Try updating your chart with this configuration and see if the waveform is now centered within the visible chart area with a fixed label. If the issue persists, please check that the data is being correctly passed to the display EG data function and that there are no additional transformations applied to the data before it's rendered in the chart.
Yes, it works. It's a problem. Can you regenerate the necessary CSS code? Yep.
Certainly, let's update the CSS to ensure it supports the chart configuration adequately. We want to make sure the chart container is styled correctly so that it accommodates the entire chart without cutting off any of the waveform. Here's the revised CSS. Key points. The #eg-chart-container is given a percentage-based width to be responsive to the parent container size, with a maximum width set to ensure it does not become too wide on larger screens. Height is explicitly set, and overflow properties are configured to allow for horizontal scrolling while hiding vertical scrolling. Aesthetic properties like background color, border, and box shadow are optional and can be adjusted to fit the style of your application. Apply this CSS to your application and ensure that the JavaScript dynamically sets the width of the #eg-chart canvas based on the data length. This combination should provide a visually consistent and functional scrolling chart area. If further refinements are needed, let me know.
Yeah, nothing works. Do we need to adjust anything else as well for this to work? Yep.
With the updated CSS and the JavaScript configuration provided, the chart should render the EEG data correctly and the waveform should be centered around 0 on the y-axis. The label, EEG signal, should appear as a static title at the top of the chart and should not scroll with the data. However, here are a few additional checks and steps to ensure everything works as expected. Chart.js library and plugins. Ensure that you are using the correct version of Chart.js that supports the features being used. Also, if any plugins are referenced, such as the annotation plugin mentioned earlier, they need to be included in your project and imported correctly. Data integrity. Confirm that the data being passed to the display EEG data function is correctly formatted and pre-processed. If the data contains nans, infinities, or other irregular values, it can affect how it is displayed. Responsive design. If the chart needs to be responsive to window resizing, you may need to add an event listener to handle window resize events and update the chart accordingly. External CSS styles. Ensure that there are no conflicting styles from other CSS that may override the styles specified for the chart. Browser testing. Test the chart in different browsers to rule out any browser-specific rendering issues. Debugging. If something isn't working as expected, use the browser's developer tools to inspect elements, check for errors, and debug the JavaScript code. Server-side rendering. If your page is rendered server-side by Flask, ensure that the data is being correctly sent to the client side and the template rendering is not causing issues. Once you've gone through these checks and confirmed everything is set up correctly, your chart should function as intended. If you encounter any specific issues after these steps, please provide details, and I'll be happy to help you TR.
It's the current CSS that I have. Can we keep using the color palette for the project everywhere? Not use any other colors? Also, I'm still having the same problem where the signal is not centered in the middle of the chart. When I remove the EEG chart container code from the CSS, it is working okay. So that probably needs to be redone. Yep.
Given the additional context that the chart displays correctly without the #EEG-chart-container CSS, it seems the issue might be with how the container is interacting with the chart canvas, particularly the height of the container or the chart. If the waveform is centered correctly without the container CSS, it could be that the chart's dynamic sizing is being constrained by the container's fixed height. Let's adjust the CSS to give the chart more flexibility while still adhering to your color palette and design requirements. Here's the updated CSS, incorporating your provided color palette and removing any constraints that might interfere with the chart's rendering. By removing the fixed height of the #EEG-chart-container, we allow the chart to define its own height as set by JavaScript, which should help in centering the waveform vertically. Make sure that in your JavaScript code, the canvas height is dynamically adjusted if necessary to fit the chart's data. Also, since you've mentioned that the label should be part of the chart and not move with the scroll, we removed the absolute positioning from the .eeg label class. Instead, as previously mentioned, you can handle the label positioning within the chart using Chart.js title or plugin features. Please update your CSS with these changes and test to see if the issue with the signal alignment is resolved. If the problem persists...
Okay, it's working better now, but the chart is too high and it doesn't fit the current window. How do we fix that? Yep.
If the chart is too high and doesn't fit within the current window, this suggests that the canvas height is too large or not being set correctly. To ensure that the chart fits within the viewable area, we need to adjust the height of the chart within the JavaScript code that creates the chart instance. Let's revise the JavaScript function to dynamically set the height of the canvas so that the chart fits well within the viewable area. In the CSS, you can also set a max height for the chart container if needed to ensure it does not exceed a certain height. The aspect ratio variable in the JavaScript code controls the height of the chart relative to the width of the container. The ratio can be adjusted to fit your design needs. Additionally, by setting maintain aspect ratio true in the chart JS options, the chart will maintain this aspect ratio even if the container size changes. Implement these changes and check if the chart now fits within the current window. If the chart is still too tall, you can adjust the aspect ratio or the max height values as needed.
Okay, adding this bit seemed to have did the trick, and it's now working much better. Yep.
Fantastic. I'm glad to hear that adjusting the maximum height for the chart did the trick and that it's now working better for you. If you need any more assistance with fine-tuning your application, whether it's additional styling, functionality enhancements, or debugging, feel free to reach out. Your project is quite interesting, and it's great to see it coming together. Remember, small adjustments can sometimes make a big difference in the user experience, so it's always worth reviewing and refining the details. Good luck with the rest of your development, Dr. Benno.
Right, shall we continue for a bit longer? It's a bit odd that it has this sinusoids in it. Regards the EEG data, it's a bit odd that it has a sinusoid as a baseline EEG. It doesn't look realistic. Yep.
If the EEG data generated for your application doesn't look realistic and seems off, it may be due to the synthetic nature of the data or the parameters used to generate it. Realistic EEG data should reflect the complex oscillations and signal variability found in actual brainwave patterns. Here are a few suggestions to improve the realism of the generated EEG data. Baseline oscillations. Ensure the baseline EEG oscillations reflect realistic brainwave frequencies, like alpha waves around 8 to 12 Hz, beta waves around 12 to 30 Hz, etc. The amplitude and frequency should be within realistic ranges. Noise and artifacts. Real EEG data often contains noise and artifacts that are not perfectly periodic or uniform. Consider introducing random noise and varying the artifact patterns to more closely mimic real-world signals. Signal complexity. Real EEG signals are not just a single frequency sine wave. They're a mix of several oscillations from different brain regions. You could layer multiple sine waves of different frequencies and amplitudes to simulate this complexity. Use recorded data. If possible, consider using segments of real EEG data as your baseline. This data can sometimes be obtained from open-source datasets if you do not have access to actual EEG recordings. Here is an example modification to the data generation code that introduces more randomness to the signal. In this example, the generated EEG signal is a mixture of alpha and beta waves, with some Gaussian noise added to simulate a more realistic EEG signal. Remember, the key to realism in synthetic data is complexity and variability. Try tweaking the parameters and layers of your signal until it visually resembles the complexity of a real EEG waveform.
Yeah, leave it as is for now, and we'll continue in a bit. Bye. Leave you with some music. Hope you like it.